All right, students, I wanted to go over number 4 and 5. You can see them right there. This is from day 54 because these are some important problems. So for number 4, again, starting with the momentum conservation equation, initially neither the male nor the female are moving, so their momenta are 0. Afterwards, they are going to be moving, so they will have momentum, each of them. I put M for male, F for female. Plugged in the mass of the male. I don't know the velocity of the male. Plugged in both for the mass and the velocity for the female after the push. And then basically went through the steps of solving for the velocity of the male after the multiplication. Moved this to the other side. Divided both sides by 62.1 kilograms. And then wrote my answer in 3 sig figs, 4.29 meters per second. For number 5, so this is complex. We've got a cannon mounted to a cart, and then there's a cannonball inside the cannon. The cart and the cannon are always going to be stuck together, and before the explosion, they're actually all 3 together. So that's what this says. Initially, all 3 objects are moving together, so you can treat them as one object. After the explosion, this is the final part, the cart and the cannon are still together, but the ball is separate. So initially, we've got the mass of the cannon, the cart, and the ball, which I wrote right here, times the velocity of the cannon, cart, and the ball, since they're all moving together, and that's that 1.27 number. That's the initial side. On the final side, after the explosion, the cart and the cannon are still going to be together, so I'm going to consider their mass together like this, and the velocity of the cart and the cannon is going to be the same, just like today in class when I had the same velocity as the pin that someone tossed to me. That's our unknown. That's the velocity of the cart. The velocity or the momentum of the ball is going to be the mass of the ball times the final velocity of the ball. And now we just go through the motions of solving. So, I guess I forgot to write it right there. So here we've got the mass. I added them all up times the velocity, and if you multiply that, you get this. I kept all the digits. I'll do sig figs later. Here, the mass of the cart and the cannon is 3.5 kilograms times the velocity, and then here, I forgot to write it, but the mass is, I hadn't solved it yet, it was 0.1054 kilograms times 75 meters per second. Oh, that's horrible. And when I do that, I get this. So, now just doing some more algebra, I'm going to combine like terms. I'm going to move this 7.905 kilogram meters per second to the other side by subtracting. At this point, you should notice that this is negative, which means we're going to get a negative velocity. And you should have probably realized that earlier on. If you're launching a cannonball this way, then that means the cannon is going to recoil that way, which means the cannon is going to have a negative velocity. So, we can see that here. When we get the velocity all by itself, by dividing, this is the answer we get, negative 0.95 meters per second. And again, that's 2 sig figs because that's what we get. And that's it. Send me a message on the Remind app if you have questions. Thanks for watching.